The objective of this lesson is to relate the number of decimals in the factors of a multiplication expression to the number of decimals in the product. In previous lessons, students learned several strategies for solving multiplication expressions with decimals, including a hundredths grid, place value, and an area model. In this lesson, we will focus on the relationship between the number of decimals in the factors and the number of decimals in the product to use with the standard algorithm for multiplication. Let's take a look at two multiplication expressions. 3 and 4/10 multiplied by 5 and 3/10, 34 multiplied by 53. Note that both of these expressions use the same numerals in different place value placements. If we multiply 34 times 53, we get a product of 1,802. Using a calculator, we can also quickly multiply 3 and 4/10 by 5 and 3/10 to get a product of 18 and 2/100. Looking at both products, notice that they each have the same numerals in different place value placements, just like the factors have. We can see that this situation holds true with other examples of expressions that have the same numerals in different place values. 25 multiplied by 17 is equal to 425, while 2 and 5/10 multiplied by 1 and 7/10 is equal to 4 and 25/100. By seeing this relationship, we can multiply decimals in the same way we multiply whole numbers, as long as we know where to place the decimal. To expand on this, let's look at 2/10 multiplied by 4/10. Recalling our previous lessons, a tenth multiplied by a tenth will be a hundredth. So the product will be 8/100. 2 multiplied by 4 is 8, and a tenth multiplied by a tenth is a hundredth. To recognize the pattern and relationship between decimal factors and the number of decimal places in the product, let's refer to our decimal product chart. A whole represents 0 decimal places. A tenth represents 1 decimal place. A hundredth represents 2 decimal places. And last, a thousandth represents 3 decimal places. We can now identify a pattern created between the value of the decimals in the factors and the value of the decimals in the product. By adding the number of decimal places in the factors together, we can calculate the total number of decimal places in the product. Knowing that decimal factors can be multiplied like whole numbers, and understanding how to calculate the number of decimal places in the product, we can multiply decimals using the standard multiplication algorithm. Take 2 and 15/100 multiplied by 4 and 3/10. 3 multiplied by 5 is 15. 3 multiplied by 10 is 30. 3 multiplied by 200 is 600. 40 multiplied by 5 is 200. 40 multiplied by 10 is 400. 40 multiplied by 200 is 8,000. Totaling up our partial products, we arrive at a product of 9,245. Since our original factors are decimals, we need to total up the number of decimal places in our factors to know the number of decimal places for our product. 2 and 15/100 has 2 decimal places, and 4 and 3/10 has 1 decimal place. 2 plus 1 is 3. Therefore, our product will have 3 decimal places. Our final answer is 9 and 245 thousandths. The objective of this lesson was to understand the relationship between the number of decimal places in factors and the number of decimal places in the product to aid us in using the standard algorithm to multiply decimals. We met this objective by recognizing that decimals can be multiplied just like whole numbers, and identifying the relationship pattern between decimal factors and decimal products.